All right, so good evening. Today is Friday, November 26th, and we're starting relations and function. So this is how I would start. I would start by saying that a relation is a set of ordered pairs. The diagram that you're seeing in front of you is called an arrow diagram. And this is an example of a relation. So this is an example of a relation. And the relation here is, this relation that is displayed is, the relation is the birth month of. So the values on the left, they're called domain, and the values on the right, they're called codomain. The arrows, whenever you see the arrows read is mapped onto. That's how you read the arrow. So what this is saying is that April in the domain is mapped to Africa in the codomain. May in the domain is mapped to Josiah in the codomain. And September in the domain is mapped to Geraldine in the codomain. And December in the domain is mapped to Joel in the codomain. So in essence, all that this is saying is April is the birth month of Africa. September is the birth month of Geraldine. May is the birth month of Josiah. December is the birth month of Joel. So this example of a relation is called a set of order, is called an arrow diagram. Now, the same relation may be expressed as what is called as a set of ordered pairs. Now, essentially, a set of ordered pairs consists of the domain element, comma, the codomain element in bracket. It's almost like a coordinate. As a matter of fact, I think later on you'll see that a set of ordered pair is a coordinate. All right, so this is called a set of ordered pair, or this way of expressing a relation is called a set of ordered pairs. And the two things are essentially saying the same thing. So one, the arrow diagram, and two, the set of ordered pairs is saying the same thing. Both are expressions of the relations of the relation is the birth month of. So some features. One, the arrow diagram and the set of ordered pairs are expressions of the relation is the birth month of. The arrow reads is mapped onto. The arrow relates element in the first set called the domain with elements in the second set called the codomain. The first element in each ordered pair is the domain element, and the second element is the codomain element. The second element in each ordered pair is also referred to as an image.
Excuse me, sir.
Go ahead.
Sir, for the second circle, sir, the codomain, sir, isn't it supposed to be called the range?
It's called a range under a particular circumstance. So you will come across it. It's called a range under a particular circumstance. All right. But the more general name for it is the codomain. You good?
Yes, sir.
Now, the second element in each ordered pair is also referred to as an image. So Africa is the image of April, etc. Turning the page. Now, a relation is also called a mapping. A relation is also called a mapping. So the next thing I want to look at are the different types of mapping. So here we have the first diagram is showing a one-to-one mapping or a one-to-one relation. Now, a one-to-one relation is a relation in which no element in the domain has more than one image in the codomain. In other words, every element, every element in the domain is mapped to one element in the codomain, or every element in the domain that has an image is mapped to only one image in the codomain. So a relation in which no element in the domain has more than one image in the codomain is called a one-to-one mapping. This says one to many. Now, a relation in which at least one element in the domain has two or more image in the codomain. So here, this one element in the domain has two images in the codomain. That one element in the domain has two images in the codomain. This is called a one-to-many relation, because one is going to more than one is going to many. Another type of mapping this says many to one. Many to one. Now, this is a relation in which at least one element in the codomain is the image of two or more elements in the domain. In other words, this one element here in the codomain is the image of two elements, in the domain. So here we have what? Many going to one. This is called a many to many, many to one relation. All right, turning the page. Then you have a many to many relation. Now, a relation in which at least one element in the domain is the image of two or more elements in the one element in the codomain is the image of two or more elements in the domain, and at least one element in the domain is mapped onto two or more elements in the codomain. In other words, many to many mapping is a combination of the one to many and the many to one. A many to many mapping is a combination of the what? One to many and many to one mapping. So if we look at our diagram, we see that the element A in the domain is mapped to 4. A is mapped to 4. And A is also mapped to 1. So that is one going to many. We can also see that that E is going to 4 and A is also going to 4. So that is many going to what? 1. So what we have is a combination of one to many and many going to 1. When you have a combination of one to many and many to 1, that type of mapping is called a many to many mapping. All right. So let's have a look at the different ways of representing a relation. Now, one way you can represent a relation, maybe not all relations, but one way you can represent a relation is as an equation. So y is equal to 2x minus 3 is an equation. And this equation is an example of a relation. The equation tells you how x and y relates. It tells you what to do to the values of x in order to get the corresponding value of y. So the first way, or one way of representing a relation, is a relation can be represented as an equation. Stay with me. Now, the same relation, y is equal to 2x minus 3, can be represented as a set of ordered pairs. Now, a set of ordered pairs is simply corresponding values of x and y from the same equation. All right, sorry about that intermission. So now a set of ordered pairs is simply corresponding values of x and y from the same equation. All right, so what I did here, this table here is called a table of values. And essentially, your table of values is used to calculate values of y for a given set of values of x. Your table of values is used to calculate the values of y when you have a set of values of x. So what I did is I selected some values of x from x is equal to -3 to x is equal to +3. Now, according to the relation, if I have a value of x, the first thing I need to do is to multiply it by 2. To get the value of y, the first thing I need to do with my value of x is to multiply it by 2. So let's multiply by 2. 2 times -3 is -6. 2 times -2 is -4. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Now I'm using my table of values to calculate, to get corresponding values of y for a certain set of values of x. Now, after I multiply my value of x by 2, I'm then going to subtract 3. So we're going to -3 going across. Now, -6 minus 3 is -9. -4 minus 3 is -7. -2 minus 3 is -5. Remember, if the signs are the same, you add and keep the sign. 0 minus 3 is -3. 2 minus 3 is -1. 4 minus 3 is 1. 6 minus 3 is 3. So when x is -3, y is -9. When x is -2, y is -7. When x is -1, y is -5. When x is 0, y is -3. When x is 1, y is -1. When x is 2, y is 1. When x is 3, y is 3. Guys, the first way to represent my relation is to represent it as an equation. The second way I can represent my relation is as a set of ordered pairs. Now we're going to use this set of ordered pairs and represent our relation as a graph. So these are the coordinates we're going to be plotting. -3, -9, -2, -7, -1, -5, 0, -3, 1, -1, 2, 1, and 3, 3. We're looking at the different ways to represent a relation. We have looked at 2. A relation may be represented as an equation. A relation may be represented as a set of ordered pairs. And now we're going to represent our relation as a graph. Let me ask you a question though. Y is equal to 2x minus 3. What type of graph you think that is going to be? Will that be a straight line graph or will it be a graph that looks something like this? Which one?
Sir, it would be a graph that is curved.
You think it will be a graph that is curved? All right. That's one answer. Anybody else? Y is equal to 2x minus 3. Do you think it will be a straight line or a curve? You know what this tells me? You all are not very observant. Y is equal to mx plus c is the general format of a linear equation, and the graph of a linear equation is a straight line. This graph is going to come out to be a straight line. Guys, we need to be more on top of what we're doing. Let's finish. So minus 3 minus 9 is this point. This is the line x is equal to minus 3. This is the vertical line x. This is the vertical line. X is equal to minus 3. And this is the horizontal line. Y is equal to minus 9. Where the 2 points meet, 2 lines meet, that is the point. That is the point minus 3, minus 9. The next point is minus 2, minus 7. That would be here. Then minus 1, minus 5, which would be here. Then 0, 0, minus 3, which would be here. Then 1, minus 1, which is here. 2, 1, which is here. And 3, 3, which is here. Now, if I use my ruler and connect these points, I should end up with a straight line. Now, because I have this wicked technology, I'm able to do that. So this is the graph, slightly off. So let me fix it. Guys, this is the graph of y is equal to 2x minus 3. And you should have known from coordinate geometry that for the equation y is equal to 2x minus 3, you're going to get a straight line. The gradient is positive 2, and the y-intercept is minus 3. So we have looked at 3 ways of representing a relation. We represent a relation as an equation, a set of ordered pairs, as a graph, now as a arrow diagram. So this is how we get our values over here. It's 2 times minus 3, minus 3. This gives you minus 9. 2 times minus 2, minus 3. This is minus 7. 2 times minus 1, minus 3. This is minus 5. 2 times 0, minus 3. This is minus 3. 2 times 1, minus 3. This is minus 1. 2 times 2, minus 3. This is positive 1. 3 times 3. Sorry, 2 times 3. 2 times 3 minus 3, this is 3. The third way of representing the one relation is as an arrow diagram. So now, x in the domain, this is the relation in which x in the domain is mapped onto 2x minus 3 in the codomain. All right, so we've just looked at 4 ways of representing a relation. All right, I'm going to stop here.